All right, good morning, everyone. Glad to have you here. This is day 3 of Build. I know there's a lot of great sessions going on right now and also some cheering. It sounds like a casino out there. So we appreciate you stopping by our session. I think we can make you 2 promises at least today. One is, this is probably one of the few sessions at Build where you're not going to hear too much about agents. So if you're a little bit agent out, this is a good place to be. The second one is, I think, unique, which is this, I think, is going to be the only session where you're going to see 2 product managers on stage talking about how to use less of their product. Okay, so we're here to help hopefully save you some money, hopefully take some of that and put it back into bring more applications on, but that's kind of the goal for today. My name is Sean McKenna. I lead the Cloud Native product management team here in Azure, and I'm joined by...
I'm Casey. I'm a product manager on the AKS team, and I work on everything cost management and optimization. So super excited to chat with all of you today.
All right, so let's start by talking about some of the challenges that we see when we talk to customers about cost. The first is, obviously, in this age of AI, I promise I'm not going to spend too much time talking about it in AI, but in the age of AI and these amazing AI development tools that we have at our disposal now, it's so much easier to go from idea to reality very quickly. But of course, you want to do that in a way where you can get those ideas out, but not necessarily sign up for a huge amount of cost up front. So how do we enable you to build those MVPs, get those prototypes out there, test the waters on a new idea without breaking the bank necessarily right out of the gate? And then as you start to see, hopefully, growth of that application, how do you have that growth not be accompanied by effectively directly linear growth of your costs, right? We want to see that cost line be somewhat sublinear, at least, to the growth of the application. Then once we've got that application up and running, how do we actually see what the costs are that we're incurring, right? What we measure is what gets done, and so we want to be able to visualize those costs. And last but not least, we have a lot of instances now where we've got multiple teams, different groups of developers that are contributing to larger applications. How do we ensure that those different development teams can see their specific costs and have some accountability around the costs that they're incurring on behalf of the business? So those are some of the core challenges that we hear. Now, you might be wondering, what is the intent of having cloud native as the central sort of organizing theme of the talk? Well, cloud native is one of these terms that our industry has churned through and watered down and overloaded in a lot of ways. I certainly have spent many hours of my life in meetings debating what is and is not a cloud native application. And so, there is that to acknowledge. But if you look back at the original intent of cloud native, it was really about the idea of how can we take advantage of the unique characteristics of the public cloud to be able to build applications in a way that was not possible before when we were running with sort of statically allocated infrastructure on-prem, right? So how can we build applications that are going to dynamically scale from a very small footprint out to potentially a massive global footprint? How can we build applications that are going to be resilient? We sort of, as part of the public cloud, we took the premise that hardware is going to fail occasionally, which made us build more resilient applications, but also made it so that our applications could move around between infrastructure, which allowed us, in theory, to save costs. We build those more granular microservice applications and then really build some automation around it. So there was some of these core tenets in the original definition of cloud native that had a lot of tie-in to the potential to save costs, right? And yet, what we see in practice in the wild, and there's many industry surveys that really support this, is even after customers adopt cloud-native platforms like Kubernetes, we still see relatively low utilization, oftentimes in the sort of low teens compared to what we would like to see much significantly higher than that. We also see a lot of customers who, after they make that pivot, they actually see some of their costs go up. There's some data that suggests that even up to 50% of customers see their costs actually increase as they adopt cloud native, which is certainly not what we want. And frankly, when we have conversations with customers around their adoption of cloud native, one of the concerns that we hear, kind of regardless of where they are within their cloud native journey, is concern about unpredictable costs as they take that next step, whether it's building that first application or bringing the 10th or 100th application on board. What is that cost profile going to look like? And so our goal for today is to help you architect your applications so that they can both scale, but scale in a fashion that's going to be cost effective, that's not going to break the bank. Talk about some of our latest cost saving tools and techniques, and really help you, again, monitor and manage those costs. So not only are you optimizing them, but being able to prove to your boss that you have in fact optimized them so that you can get back to building all the cool agents that you've heard about in every other session build. All right, so with that, we're going to start out by talking about serverless. So I mentioned cloud native has this kind of core tenet around being able to just pay for what you use, have dynamic scaling. Serverless obviously took that one step further because you don't even have to have a minimal footprint necessarily to get started. You can start from literally zero and begin to scale up. And within Azure, when we talk about cloud native and serverless, our serverless container platform is Azure Container Apps. And so as I mentioned earlier, being able to take some of those great ideas that you have and go with some of our AI-assisted development tools very quickly to production, ACA is a perfect solution for that. It's very quick to get started. It's very application-oriented. You pay for exactly what you need, and you can actually scale all the way down to zero. You can configure auto-scale rules based on a number of different triggers, whether it's HTTP requests, messages dropped into a service bus queue, files dropped into a blob store, what have you. So it makes it really easy to have those kind of small MVP applications very quickly get out to market and then be able to scale up quickly as required. All right, so with that, enough initial chatter. Let's take a look at our first demo. Now, I mentioned this notion of having ideas that you want to really quickly get out to market. So I'm coaching my kids' Little League team for the first time this year, and that's mostly fun, but there's this one task that is kind of a pain, which is creating the lineup for the team. Has anybody coached Little League before? Yeah, so you know what I'm talking about, which is you have to balance not having the same kid play left field every single inning, but also maybe that kid can't actually pitch, right? And so you could do this Excel magic to try to make sure that you're balancing everybody getting a good shot and playing a fun position, but also being able to keep the game moving because not everybody can play every position proficiently. And so I thought, hey, let me go build that out as an application. Maybe I'll share it with my fellow coaches. And if they like it, great. But otherwise, I don't want to sign up for a big amount of cost. So what I've got here is I've got a React application on the front end that's running inside of Azure Static Web Apps. Then I've got my API layer that's actually going to do the lineup generation, calculate statistics, and a number of other things. That's going to run inside of a container, inside of Azure Container Apps. And then my backend is running in an Azure database for PostgreSQL, running in the flexible server, so kind of the lightweight configuration of Postgres. So if I go in here to my Little League lineup container app, you can see that my revision currently is sitting at 0 replicas, right? So it's literally scaled all the way to 0. And that front end app is just being served from Static Web Apps. So what I'm going to do is I can go in here. I can go to the roster. Now what you're going to see is it's going to take a couple of beats because now it's hitting the API. It's going to go spin up that container. I'm not really that worried because it's still going to be faster than me fiddling around with my spreadsheet, but it's bootstrapping that first replica to be able to bring back the data for my team that I can then go and do some configuration of my roster. And there you can see I've got all of the positions here. I can go in and say, Adam can pitch, but he can't catch. And maybe Charlie wants to play first base and shortstop, but he's going to get to play the outfield sometimes too. And now once I've got all of that configured, I can go into the lineup screen here. Not every kid shows up every day, so I can select Brianna's not going to be here at the game this weekend, and then I can go create a game, and it's going to spit out the lineup for me, much faster than my Excel spreadsheet. So this is cool, this is useful for me. I could have run this locally though, but I want to put it out to my fellow coaches to see if this is something that would be valuable for them as well. And so as I do that, I have no idea what the load is going to look like. So let's sort of do a simulation of what bringing some load onto this application would look like. If I can start a watch here, and you'll see, because I hit that initial roster, I've got a couple of replicas that have now spun up, and I'm going to go and run a load test against that, and we'll start to see as those additional requests come in, kind of simulating additional coaches coming in and creating their lineups, that we'll start to spin up a number of additional replicas. So while that's happening, let's take a look at the scale rule that is actually driving this behavior. Oops. You can see some of those tests are now firing up. We'll see that replica start to grow. But what's actually driving this is right here, the scale rule that dictates I have upwards of 50 replicas all the way down to 0, as mentioned. This is an HTTP-based scale rule. And I'm doing something slightly unrealistic here for the demo, which is I'm saying I can only accept one concurrent request. So if I have more than one concurrent request coming into this container, it's going to spin out additional containers. Naturally, you would do your performance testing and determine what your actual capability is. But you can see now I've spun up to 11 replicas here, and it's going to continue to grow. Going to continue to grow as that load test continues to run. But let me go ahead and stop that load test now. Oops. And as I do that, it's going to start to actually scale down. And so as my coaches stop doing their testing, it'll start to actually scale down. I can go all the way back down to 0, at which point I'm no longer paying any cost for those replicas.
So Sean, why not scale every app down to 0 then, if there's such clear cost savings of you only pay for the compute that your containers are needing?
Yeah, it's a great question. So as you saw when I tried to bring up the roster for the first time, there was that few seconds that it took to actually spin up, right? So that's not the greatest user experience, obviously. And so there is an in-between state where I can leave at least one replica running and in what we call an idle state. And in that idle state, you'll actually pay not 0, but less than you would if it was running at sort of full speed. And that can improve that cold start time rather than waiting for the container to actually spin up entirely. So obviously there's some trade-offs there in terms of the user experience relative to the costs that you are incurring that you'll just want to play around with. In my case, I'm cheap. I don't really care if my fellow coaches have to wait 15 to 30 seconds, still better than their Excel spreadsheet. And so I'm willing to take that trade-off, but maybe if it started to pick up a little bit more, I'd maybe change that decision. But as you can see now, it's scaled all the way down to 0 replicas here, and I'm no longer paying anything. All right, so I talked about serverless containers as a sort of general notion, but in fact, it's a little bit more nuanced than that when we talk about ACA. There are different pricing plans that you have options to play around with. So when you're starting out, you've got the very basic consumption plan, which is literally at the application level, pay for exactly what your application is incurring, right down to sort of the very finest grain choice of resources. Now, typically, as your application grows a little bit, gets a little bit steadier in the traffic that it's seeing, it can become more cost-effective to actually shift to what we call a dedicated plan, which not only gives you some quicker cold starts, it also gives you single-tenant isolation, but gives you access to specialized premium SKUs if you want to use GPUs, for example, and ultimately at a certain scale is going to become more cost effective as well, because at this point, rather than paying right down at the granular level of the application, you dedicate what's called a workload profile, which gives you sort of a pool of resources that you can deploy one or more container apps into and then scale within that. And so there are those kind of click stops as we go and as your application evolves and grows and gets steadier traffic. Now, there's one further tipping point that we often see, which is once you get to a larger scale and a steadier scale, it often becomes more cost effective to look at actually leveraging a more sort of infrastructure-oriented solution. And in fact, the typical tipping point we see is if you can get to about 20% utilization on your virtual machines, then it's usually going to be more cost effective to run in an IaaS-based environment using something like AKS. But as we saw earlier, most customers don't actually get there. They're sort of stuck in that sort of 10 to 15% range. So Casey, how can we actually help people get over that hump where they can get even more cost benefit by running on something like AKS?
Yeah, let's talk about scaling on AKS. And we'll actually, if I can grab that, thank you. We will start with a customer example. So the ODP Corporation, probably best known for Office Depot. They are an example of one of our retail customers that are building on top of AKS, containerizing their applications, as well as using AI Foundry to actually create AI agents that help with HR, sales, and retail. And they've been able to do all this innovation and keep costs down by leveraging some of our scaling tools. So let's talk about our scalers on AKS and see how they can help you as well be cost effective from day zero. So on AKS, scaling comes in two forms. There's application scaling and there's infrastructure scaling. And all of our AKS autoscalers are what we call managed add-ons, which are built on top of open source vendor neutral CNCF projects. What we mean by managed add-on is also that we as AKS own all of the upgrades, the patches, the versionings of these tools, so you don't have to worry about the configuration and you can just focus on deploying and developing applications. And this is true not just for our autoscalers, but actually most of AKS add-ons are built on top of open source tools, which is something we're super proud of, is just the continued contribution and collaboration with our upstream communities. But going back to application scalers, so we have two dimensions. There's horizontal and vertical. Horizontal pod autoscaler will scale dynamically the number of pod replicas in your cluster based on demand, based on metrics such as CPU and memory utilization. Vertical pod autoscaler goes in the other direction. So instead of changing the number of replicas, it'll change the size of your pod, adjusting the resource request and limit values for CPU and memory based on now historical utilization. And our last application scaler is Kubernetes Event-Driven Autoscaling, or KEDA. This actually builds on top of HPA and will scale the number of pods, not just based on CPU and memory metrics, but also on event triggers. So anything like Azure Service Bus Queue, Prometheus metrics, HTTP requests, there's a lot. There's over 70 plus built-in scalers that is supported by KEDA.
And if that sounds familiar to what I was mentioning in the context of ACA, it's because the ACA autoscaling capability is in fact built on top of KEDA. So when we think about this sort of spectrum of options within our cloud native portfolio, there's a lot of reusable, transferable skills. So if you've built a scaler in an ACA application that's based on, say, a service bus queue, you can configure something very equivalent inside of AKS.
Yes, exactly. And one last call out for VPA, actually. We now, with the support of Kubernetes version 1.33, which we actually just previewed on AKS about a month ago, VPA actually supports in-place pod updates, which means it no longer requires a pod restart to actually go in and change these pod request and limit values, which is huge. It makes VPA kind of a no-brainer to start using for cost savings.
There's a lot of people that have been waiting a long time for that.
And hopping over to infrastructure autoscaling. So on AKS, we have cluster autoscaler, which will change the number of nodes in your node pool based on pending pod requirements and scheduling those pods. And then we also have node auto provision, which will actually dynamically pick the most cost-effective SKU for your workload based on pending pod requirements as well. And let's actually look at a visualization of the two side by side. So the first biggest difference is with Cluster Autoscaler, it works on this concept of pre-created node pools. So it'll scale up the nodes in a node pool up and down. But you do need to have dedicated node pools if you want to have a mix of SKUs in your cluster, for example. It's the same for if you want a mix of on-demand and spot. You'll have to have a dedicated node pool for on-demand, dedicated spot node pool. And you kind of need to know upfront what SKU is best for your workload. Is it a memory optimized? Is it a commute optimized SKU? You'll have to do that decision-making process up front. Versus node auto provision will actually create the nodes for you ad hoc as needed, and you don't need to know the SKU type exactly up front. NAP can pick from all the Azure SKUs. It can be one of the SKUs supported by Azure Boost. It could be Cobalt. It could be a GPU-specific SKU. NAP completely removes that decision-making process for you and will pick the SKU based on exactly what the pod requirements and what your application needs.
But Casey, I've spent so much time memorizing all of the Azure SKU names. What am I going to do with this knowledge anymore?
Yeah, the SKU names are like a foreign language. They're very hard to parse, but that's a great opportunity to use Copilot and actually plug in those names, how to explain to you how the naming conventions and the lettering works. I've personally done that, and it works great.
Now, this sounds great, that I can turn over responsibility for deciding from all those inscrutable VM SKUs to the service. But my finance guy told me that he got a really sweet deal on some VM families, and he really wants to make sure that we use those first. Is that still going to be possible, even though I'm sort of abdicating my responsibility here?
100%, and we'll actually show that in this upcoming demo, where you can specify to NAP if there are specific SKU families or types that you want to get prioritized and have NAP pick first. There is a way to do that through the node pool definition, and we'll go through that in a second. And the second biggest difference to call out here is how consolidation happens. So with Cluster Autoscaler, it'll simply scale down the number of nodes in a node pool if a node goes underutilized or if there are no longer pods running on that node. Versus node auto provision will actually consolidate workloads from across different nodes of different SKUs into an existing node or a new node that might be a more cost-effective, cheaper SKU than the nodes that were already existing. So it's pretty cool what NAP can do here. Another exciting announcement coming in public preview and actually rolling out right now is cost-optimized add-on scaling. So this means that managed AKS add-ons like Core DNS, Retina, Image Integrity, and Workload Identity can be scaled, which means that our system components and these managed add-ons are taking as little space as possible on your nodes, just opening up more space on your nodes to run actual workloads and applications. So this is, you're already paying for this compute. Now you just have more space to run actual workloads. And we'll continue to support more of our AKS add-ons with time. And if there are specific ones that you'd like to see supported, do let us know. And lastly, we also announced generally available is AKS cost recommendations in Azure Advisor. So all these recommendations are aligned to our AKS cost best practices and are specific to your cluster configuration. They are targeting 4 initial scenarios, so workload right sizing, cost allocation, auto scaling, and SKU selection. And we'll actually go ahead in our demo right now and have a look at how to implement like VPA for workload right sizing and auto scaling. So in my demo, I'm using this pretty classic e-commerce architecture. I have a storefront web app for my customers to browse and place orders, a store admin web app for my employees to view orders in the queue and go and update products. And then I have various services, order service for placing orders, product service for performing CRUD operations on my products, and then a make line service for processing orders off of the queue.
All right, let's see it.
We will hop into this demo. There's quite a few features that we will be showing here, so let's go ahead and pull that up. Okay, so I'm going to start here in the Azure portal in my subscription scope. And I'm going to first look at my advisor recommendations. So this covers all of my clusters within my subscription. I can see that for Kubernetes service, I actually have 4 cost recommendations that are present here. The 4 scenarios that we had just talked about, so Spot, VPA, using cost analysis for cost visibility, and then auto scaling with Cluster Autoscaler. And you can actually click into specific recommendations, see the additional details, see which Kubernetes cluster is being impacted, and then go and take action. So now I want to hop over to the terminal, and I've already pre-set up an AKS automatic cluster. I chose an automatic cluster over a standard AKS cluster because as a first-time developer and deploying my first application to AKS, I didn't want to worry about all the configurations from networking and security and scaling. There's a lot to know with Kubernetes and a lot to know with AKS, right? So with AKS Automatic, that handles that all for me, all of the best practices, all of the guardrails and safeguards for running reliably, securely, are all set up for me already. And all my scalers actually, so VPA, Kata, and NAP, which we'll demo, are already pre-enabled on my cluster, which is awesome. So here we can see my application, all of the different components are running in my cluster. And I actually want to go ahead and describe one of my storefront application pods. Right here, you'll see that I have 2 storefront pods. So kubectl. And let me grab one of these pods.
You missed the L.
Oops, thank you. And the first thing we'll see here is that I actually haven't set request and limit values for my pod. So there's nothing in this spec that shows that I've actually set requests and limits. This is a bit of an anti-pattern, but unfortunately is something that we do see happening is if you don't know how much resources your applications will need, it ends up not getting set. So let's actually use VPA to help us right-size those requests and limits and get some recommended values. So we're going to apply our VPA manifest. And that'll just take a second, and we'll apply to our pods in our cluster. And while that's getting applied, let's have a look at this manifest. So here we can see it's targeting our storefront deployment. We have a minimum and maximum allowed CPU and memory range. And we have an update policy of auto, which means that VPA will automatically apply these request and limit values for CPU and memory for us, which is pretty neat.
And as you said, that's going to happen in place now as of 1.3,
yes,
right?
exactly. So it actually won't require a pod restart anymore with 1.33. If we go ahead and look at our pods in our pets namespace again, we should see that there is a new pod that is spun up. Wow, awfully slow today. But there we, oh, interesting. Not quite yet. We'll let that keep running in the background. But in the meantime, let me go and show you my deployment. So as I had specified in my deployment manifest, for my storefront, I have 2 replicas, and I'm going down to the CPU and memory requests and limits. I actually had it commented out, but let's go uncomment that and see if VPA has kicked into action yet with our updated pod request limits and values. So normally, if it was running a lot faster, we would see recommended pod requests and limit values show up there. But for the sake of time, I'll just continue the demo. So I'm actually going to apply some CPU and memory values so that any future created pods for my storefront application will have properly set values and are able to be created out of the box. So I'm going to go ahead and save that file. I'm going to reapply my manifest. And while that reapplies and gets recreated, I'm going to hop over to the portal and talk about Kada and how we can scale up our storefront application as we have a load test running and there's an influx of demand hitting our storefront. So going back to our automatic cluster now, we can actually create a Kada scaled object and a scaled job directly in the portal. So we will go to application scaling, and I can hit create. We will call this storefront. It'll live in the pets namespace. I want my target workload to be the storefront. And for the sake of the demo, I'm going to reduce the polling interval and the cooldown period to 10 seconds, so it's a bit quicker. I want to set a minimum replica of 3, and maximum can be, much higher, but 100 is perfect for this example. And then CPU utilization of 60. We review and create that, and there we go. We have a Kada scaled object in place. And now let's go ahead and create our load test. So I have a load test pre-configured here, but let's go ahead and look at the configuration details before we kick it off. So test.
So now you're actually in our managed load testing service, right?
Yes.
Which
yes.
I think we don't talk about enough. We've got this great service that can help you load test your applications in a fully managed fashion based on JMeter. So definitely a great tool for doing testing like this.
Yeah, and actually the Azure Load Test team recently previewed a load test extension in VS Code. So you can directly in VS Code have it create a load test script for you and run it via your VS Code. It'll actually go and run it in Portal and then give you all the results. You can work with the Copilot or AI agent and actually interpret the results of your load test. So it's pretty cool. But for this example, we're just using the managed Portal experience. So for my load test details, I'm having a linear load pattern. It's going to run for 3 minutes with a 30-second ramp-up time. There are 50 concurrent users per engine with 1 engine instance. So let's go ahead and actually run this. This will also take a few minutes to run in the background, so I want to kick that off first. There we go. Looks like it was created and is starting up. So back in the CLI, when I had reapplied my manifest, I can see that there's actually a ton of these warnings, which are coming from Azure Policy, which is one of our features that is enabled out of box as a part of AKS Automatic. And these are the guardrails that will tell us things like, hey, your deployment only has 2 replicas for, avoiding disruption and crashes, consider increasing it, things like that. So in my development process, if there are things that I'm not thinking about when it comes to reliability, best practices, uptime, Azure Policy kind of takes care of that for me and reminds me, which is pretty neat.
In fact, I think it's going to remind you if you don't have resource requests.
Yes,
set,
exactly.
Right?
It
Because
will.
As you say, that's something we've seen
that.
a lot of customers naively deploy an application. Seems like it's working well. Then it scales up. Things start to fall over. They call us with their hair on fire.
Yes, exactly. And something that has changed now that we deployed Kada to scale up. So immediately we can see now there are 3 storefront pods. Remember when I created my Kada scaled object, I defined a minimum of 3 replicas versus my storefront deployment had only 2 replicas. So this is showing Kada is already kicking into action and has scaled up to ensure that there's always 3 minimum replicas there. While we wait for the load test to run, I'm also going to talk about node auto provision and Spot, as well as Kada scale job. So we're going to see Kada used in a second way today. Lucky us. So for my node pool definition, a node pool definition basically gives constraints and scopes down the pool of SKUs that NAP can provision for your workload. So what I've defined here is a default Spot node pool definition, meaning I only want this node pool to have Spot-based nodes. I can specify things like the architecture, the OS type, capacity type, so only Spot here, and then SKU family. So to Sean's question earlier about reserved instances, I may have reserved instances for these types of families or savings plans as well. This is a way that we can guarantee that Node Auto Provision prefers these SKUs before falling back to on-demand or any other SKU type. And then the last thing to show here is I've set a taint, which will ensure that only pods with a toleration for this taint will get scheduled to my spot nodes. Now hopping over to my Kada scaled job. So this is a virtual worker scaled job, and my trigger target is a Azure Service Bus orders queue, the message count of 5, which means that every time there are 5 messages in the queue, a new job will be created by Kada to go and process orders off of that service bus queue and get them scheduled to my spot nodes provisioned by Node Auto Provision. And then here's a toleration to ensure that we can schedule these jobs to our spot node. And lastly, a node affinity, which means that when there are multiple node pool definitions that Node Auto Provision can pick from to provision a node, this is a way that you can specify preference. So I've weighted my spot node pool 100. I want it to be weighted much higher than an on-demand. But if my spot node, is evicted or it's terminated, then there's always a fallback option onto the default configuration by Node Auto Provision. So all I need to do now is apply both of these files. So the trigger authentication was created for Kada, virtual worker jobs, and then one more. Okay, and while that is getting created, I'm going to go into another tab, and I'm going to use a tool called AKS Node Viewer. This is also an open source tool, and is really neat. You can actually see which SKUs, which nodes are getting created by spot, the price of that node, as well as the current utilization. So you can see that for my microservices that are running right now and my web apps, they were scheduled to this default SKU, which was provisioned by Node Auto Provision. You can see the cost, it was an on-demand node. And when the Kada scale jobs are created and scheduled to the spot node, we should see a new spot node pop up here in just about a second. One other thing that I want to do is set a watch on my storefront applications, because the load tests, if working properly, should also be kicking off new storefront nodes. So there you go. You can actually see we went from 3 storefront pods to now a whole bunch. As the load continues to run, these pods will stay alive. Once the load test is complete, these pods will actually be scaled back down to 3 replicas. All right, and it looks like, there we go. Our spot node was created. We can see that Node Auto Provision actually picked the same SKU for our spot node pool and our default node pool, but look how much cheaper our spot node is. It's quite a large savings when you're running this for a long time, and when your jobs are created, the spot node will actually get taken down. So you're no longer having to pay for a node that is up for days and days and days.
Always a bit dicey doing a spot demo, because who knows if there's going to be capacity.
Yeah. All right. With that, so everything so far we've looked at from a single cluster context. Sean, how do we then think about cost savings from a multi-cluster context?
Yeah, absolutely. Because realistically, once you're starting to run at any kind of scale, you're going to be running more than one cluster, right? In fact, we see most of our customers start to get into dozens, if not hundreds or thousands of clusters as they're running across different environments, dev, staging, production, or maybe across different regions, different applications. And so when we think about multi-cluster operations, that is ultimately the domain of a product that we call Azure Kubernetes Fleet Manager, which can do a number of different things. I encourage you to take a look at it for things like multi-cluster orchestrated upgrades, for multi-cluster configuration in a consistent fashion. You can actually enable cross-cluster service communication. It's able to do quite a few things when it comes to multi-cluster operations. But since the purpose of our discussion here today is around cost. We're going to talk about a feature of Fleet, which is intelligent resource placement. And what we're going to look at specifically is how we can take that application that Casey just showed, it running in a single cluster, and actually deploy it into multiple clusters, but with a catch, which is deploying it into multiple clusters based on a cost metric. So as many people know, we've got, 60-something regions now worldwide, and each of those regions has slightly different costs, even for the same infrastructure, right? And so if I go here into my Fleet resource in the portal, I can look at my global AAD service issue, always what you like to see. So hopefully we'll get through this. So I've got 3 clusters running here, and you can see they're running in different regions: West US, Central US, and North Central US. And if I drill in on one of these clusters and look at some of its properties here, returned in the YAML, I can see that the per CPU core cost is actually returned here as property. Now, we don't do this just for interest's sake, but we actually enable you to go and schedule based on this property. So I've got a little script here that can show me the core costs for those 3 clusters in those 3 regions, and you can see based on this, I would expect if I wanted to schedule across two out of my 3 clusters and say do it based on cost, then I think it's going to be trying to optimize to run that in inside of Central US and North Central US, because West US is the most expensive of the 3. So how are we going to do this? I'm actually going to go ahead and deploy that AKS store application into the hub cluster. So the hub cluster is itself a Kubernetes cluster. So I'm going to create a namespace for AKS store demo inside of the hub. And then I'm going to deploy that application into that namespace. Again, inside of the hub here. All in one. Store. What is tripping me up here? Okay, so that's going to go ahead and deploy into the AKS store demo cluster namespace inside of the hub cluster. It has not deployed out to any of the member clusters yet. So let's go and set up a view of those clusters. So I've got North Central in the top left, Central in the top right, West US in the bottom right. And now what I'm going to do is set up a cluster resource placement, which is a custom resource definition that's defined as part of Fleet that is going to dictate how that scheduling happens. So let's take a look at that here inside of VS Code. And you'll see this is very similar to the standard scheduling constructs that you would have within a single cluster, but now applied at that Fleet scope. So specifically here, we're going to look for the AKS store demo namespace. And then once we've got that, we're going to do a placement policy for pick n, which means pick a certain number, in this case 2. And the decision for how to do that scheduling is going to be based on the per CPU core cost as well as memory. And you can see I can actually set weights for those different properties to decide how the scheduling is going to happen. And so now if I go back over here and go ahead and apply that cluster resource placement CRD, Within a few moments, we should see, indeed, North Central and Central spin up very quickly, nothing in West US, because it was looking for where that lowest cost infrastructure was. And so I can play around with that in terms of how many I want to set up. And of course, now I might want to set up a global ingress into that cluster. And in fact, we just announced in preview the ability to configure traffic managers, or our DNS-based load balancing on top of Fleet, so that I can have a single ingress, a single DNS entry point into these multiple clusters, and it'll do the right level of load balancing across those different environments. So that allows me to set up very intelligent workload placement. Again, in this case, we looked at cost, but there's other ways that you can have the decisions be made based on the capacity in your infrastructure and other properties as well.
And I can also do it based on labels too, right?
Yep.
Not just specific clusters like the top 2 clusters, but actually labels, annotations,
Absolutely.
other ways of selecting the cluster.
Yeah. So as I mentioned, the primitives that you're used to with doing workload placement inside of an individual cluster really apply here in very consistent ways. So you're sort of just taking the concept up one level to a fleet of clusters instead of a single cluster with a set of nodes. So hopefully those skills and those primitives are something that you can transfer forward. So now we've looked at serverless containers to get us started. We looked at individual cluster optimizations. We've now done deployment across multiple clusters through Fleet. We're feeling pretty good, right, that we've optimized our costs, so we've been able to not spend too much to get our applications up and running. But Casey, now the boss comes by and says, prove to me that you've actually done well and that you're saving us money, because you've asked to go build out an agentic workflow, and before you do that, you got to eat your vegetables. So how can we prove to the boss that we're actually in pretty good shape here?
Yeah, this is where monitoring and cost visibility comes into play. So this is our last little bit. Brings me to AKS Cost Analysis add-on. So this is one of our Azure native cost allocation visibility experiences. Like I said, a lot of our managed add-ons are built on top of open source projects. This is another one. It's built on top of OpenCost, which is open source CNCF incubating project. But with cost analysis, you can get granular cluster infrastructure costs broken down by Kubernetes constructs like namespaces. This is really helpful for clusters that are being shared across developer teams. If there are multiple applications in my teams, in my cluster, and I want to see how much each app is costing me, this is a tool that can help you do that. I can look at historical trends, identify anomalies, see where idle is coming from, and also identify new optimization opportunities. So let's actually see what this looks like in the Azure portal. Oops. So let me hop back to the Azure portal, and I'm going to start from my subscription scope once more. There's this tab called Cost Analysis under Cost Management, and I want to look at my costs by Kubernetes clusters. And here, this is going to be an overview of all of my clusters across my subscription, across resource groups, and different regions. And I can immediately see when these were spun up, if they're trending is to be expected, or if there are big spikes, that's something to be aware of and concerned about. But I can see from a high level how much each of my clusters is costing for this month of May. If I click into a specific cluster, so this is my AKS Automatic one that we were demoing the scaling just before, I can see all of the resources. This is like a bill of resources that were created in my cluster at different points. So it would include compute resources, network and storage resources. I can see how much of each resources were actually used to run applications, how much cost is associated with system-related processes, and then how much of that resource was idle. If I click into this cluster, I can also see, this is what we call the Kubernetes namespace view. And I'll see my pet namespace, the compute, network, and storage costs, and it's pretty cool to see this actually quite low. because we had used VPA to right size these pods and we had used Kata to scale up our application. So we were able to keep these costs pretty low. So I can bring this back to my boss and say, hey, I did a pretty good job here.
And you can actually say you did better than another team, right? Because
Yeah,
you know, at the end of the day, the bill that you're getting is for your cluster as a whole.
Yeah.
But if you've broken it down into a bunch of different namespaces and you're the pets team and you've done great, but the boss can't see it because they just see the top line, you want to be able to drill in here and say, hey, my namespace is actually the best.
Yeah, and this is exactly how we would drive developer accountability. So each team that is owning their application, if there's a tangible number that we can show the boss, that ensures that each team is responsible for the spend that they're incurring. And then we can also see things here like what we call shared costs, system costs, for our add-on related system costs. These are costs that aren't associated with one particular namespace, but might be shared across all of the developer teams, all of the applications in our cluster. And lastly, we can see idle. So actually, it looks like we have quite a bit of idle compute costs. Let's go take a look at what might actually be causing that. So back in my cluster overview blade, now rather than the namespaces view, I will look at the Kubernetes assets view. This is a categorical grouping of all of my resources in my cluster, so I can click on compute. And we should see all of the compute resources that NAP was spinning up or spinning down for my scaling scenario represented here. And it looks like actually the system pool is generating quite a bit of idle, but also quite a bit of used. The reason why none of our workloads were scheduled to our system pool is because Node Auto Provision and AKS Automatic set a only critical add-ons only taint, so only the most critical AKS system add-ons get scheduled to our system node pools. We don't want mission critical applications running on those for reliability and performance reasons. So as we can see here, actually the default nodes and the spot nodes that Node Auto Provision had created for me, the costs are fairly low because these were spun up and spun down as soon as our jobs or our pods no longer needed that compute.
Can't get much better than less than 1 cent.
Yes, love to see that. And the last thing I want to show is we've looked at our cluster infrastructure costs, but let's actually look at some of the monitoring details because we want to look at utilization along with our costs to get a more complete and comprehensive picture of our cluster state. So the Azure Monitor team has released a whole bunch of cool features for AKS and optimizing your monitoring stack. One of these features is in preview called Dashboards with Grafana. These are out-of-box, pre-built Grafana dashboards that you can use at no cost as long as you're running Managed Prometheus under the hood. There's a whole slew of pre-built dashboards there, a ton for Kubernetes, but let's just pick one. Let's go and look at the node view, and we should see, I think it'll be for our default node running our web app. We can see the CPU usage, we can see memory usage. Let me pick the right node here. There we go. So you can see there's this little bump when we were scaling up our application. Since this is actually the only application I'm running in my node, we have all this available compute because we've been packed and right-sized my pet store app. We have all this space now to run whatever AI agents that you want or whatever other applications that you want. Some other interesting details here, we can see CPU usage against the requests, we can see memory usage against the memory requests and limits, and you can actually see that we're doing fairly well, better than the 10% utilization that most folks start with. So we've done some good. There's probably still some way to go, but this is a great start to optimizing our cluster and being able to see that the optimizations are actually working here.
And it is really critical that you continue to monitor it, right? Because it's not a one shot and you're done. You're going to be continuing to iterate and evolve and improve and show the boss every day how it's getting better and better.
Exactly. And lastly, so as I mentioned, Azure Monitor has a bunch of cool new features coming out. So GA is logging and events cost presets. This means you can switch from log analytics-based metrics to managed Prometheus, and this will save up to 80% of your metrics cost, which is pretty large. It is one of the new defaults for any AKS cluster that is enabled with Azure Monitor out of box, but for some of our older AKS clusters that are using Azure Monitor, you will have to go in and update the setting. Secondly is reducing your Prometheus ingestion costs with this Metrics Insights dashboard, which is in preview. You can actually see which namespaces are generating the highest volume of metrics, and you can see how often these metrics are getting queried. So if there's metrics that are never getting queried, you can consider removing them if they're not actually being utilized to save on some of those metrics costs.
Because we do see a lot of customers that are surprised by what their monitoring bill specifically
Yes.
looks like at the end of the month, right? So we talk a lot about the compute pieces and kind of where the applications are running, but when you look holistically, you need to think about your monitoring costs as well.
Exactly, and the total cost of ownership, right? Compute is a huge portion of what it costs to run AKS, but there's all these additional services like monitoring, like Grafana, network storage that also come into consideration. And then lastly, we have cost-effective alerting strategies. So simple log search alerts is in preview. This is designed to promote simpler, faster alternatives to traditional log search. Summary rules are in GA, so these are scheduled queries that run at defined intervals, and you can actually perform aggregations or transformations. You ingest your logs into basic log tables and then can perform the advanced analysis on the aggregated version of this data. And then lastly, what we had showed just now in the portal is the out-of-box Grafana dashboards, which is in preview.
All right, so bringing it all back together from where we started and some of the challenges that we talked about, here's sort of the upshot. As we talked about, cloud-native strategies can and should help you save costs. That was part of the original goal of cloud-native. And so but it's important that you leverage them correctly. It's not just a throw it on there and all of a sudden everything's going to be automatically very cheap. You do have to leverage some of these strategies to right-size your applications, choose the right tool for the job. Definitely want to consider serverless. If you're starting something new that you just want to get an MVP out there very quickly, that can be a very cost-effective way to run a sort of low-scale or dynamically scaling application. Think about the rich set of tools that we have for AKS, as Casey mentioned, and then definitely look at Fleet Manager, not just for cost savings, but if you are running more than one cluster, you will probably get some benefit by putting those clusters in the fleet. We've made that a lot easier inside of the portal, where you can just go click, 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 and add your clusters, existing clusters, to a fleet. And then last but not least, as we mentioned, you really got to be continually monitoring those costs, visualizing those costs so that you can see how well you're doing and see where there are additional opportunities for improvement. And speaking of additional things, do we have additional resources,
Yes,
Casey?
if you are ready to learn more, we have all these links where you can keep up with all of our latest and greatest. We also have a new cost management series on our AKS YouTube channel. There are a bunch of cool content that we're continuously putting out there, but check out our series on cost. We're releasing a new episode every single Monday, and our third episode just released this week. We'll cover a bunch of interesting topics, some of which we covered here around scaling, and some other new topics.
And we, last but not least, we've got a few more sessions, cloud-native sessions throughout the day. So focused on stateful workloads, really specifically diving into developer tooling and how as a developer you can get started within AKS. And then, yes, of course, we will all bring it back to AI at the end of the day and talk about how you can do all of this in a cost-effective way, running AI workloads on top of AKS. But hopefully this was useful to get you started on that cost optimization journey, save a few bucks in how you're building your cloud-native application, so now you can get back to building all of those agents that I know you're desperately looking to do. We appreciate all of your time today, and have a great rest of your build.